All right, so today we are talking about normal distributions. The first little bit that we'll cover, you guys are going to be able to determine probabilities just today through normal distribution and then values of data on the next class. Okay, so you don't have to write this down. Okay, this is going to be a really good practice of your note-taking skills. Remember, you only want to get down the important stuff. Okay, but many events with a normal distribution curve that could be the height of 20-year-old males. That could be your ACT results, the weights of newborn babies, etc., etc. A distribution curve, okay, looks just like this. You probably might have known this as a what type of curve? Say it, a bell curve. Yes, okay. Normal distribution curves do look like a bell curve, okay? So whenever, they're trying to analyze like the scores, the overall scores of like Algebra 1 results for the state of Florida, they all use a normal distribution type curve to look at this data, okay? This you definitely need to make sure you get that. All right? And as you're getting this down, okay, I'm going to talk about the different properties of a normal distribution curve, okay? So you need to make sure that, you're listening, you're actively engaged here, all right? All right, down here at the bottom, yes, these look like U's, M's. This is actually the Greek letter for mu, mu. Okay, so it does kind of look like a M with like an extra tail. Okay, so something like that. Okay, that is mu. Now, mu represents the mean. Okay, this is the mean. The mean is basically the center of your data, okay? So the very center here is your mean, okay? The mean does split up your normal distribution curve in half, okay? So 50% of your data lies this way, and then 50% of your data lies this way. So 50% above the mean, 50% below the mean, okay? Mean, average, halfway, okay? Now, you guys have seen this other little symbol before. What does that mean? Standard deviation, okay? And within your normal distribution curve, it is distributed, it is balanced like so. You have one standard deviation, two standard deviations, and then three standard deviations, okay? And it goes on both sides. Now, mean and standard deviation, those are numbers, okay? So like when you found the mean of your heights and your shoe size, and you found the standard deviations, you could actually create a curve based off of that. Okay, you create a normal distribution curve based off of the data that you've actually collected. Okay? Now something else that you need to know is that the area underneath the curve is equal to 1 or 100%. Okay? So the area, aka the probability underneath this curve, is equal to 1 if you're using fractions or 100% if you're using percentages. Okay? So the area underneath the curve, or the probabilities, will equal 1 or 100%. All right? And think about it. The mean splits your data in half. You have half below the mean, or 50% below your mean, 50% above your mean. Your one standard deviation of your mean, okay? 68% of your data actually lies within one standard deviation of your mean. Okay? So that's over 50% of your data will be close to your mean, the way that normal distribution curves are broken down. Okay? Yeah, between these two lines. Okay? Within two standard deviations of your mean, that is 95%. And then within three standard deviations of your mean, it's not 100, it's 99%, okay? Because this curve is actually asymptotic to your x-axis, okay? Meaning that the curve is going to, go down, it's going to get really close to this horizontal axis, but it's never going to cross or touch, okay? So it's going to be, three standard deviations is going to be 99%. So that means that this a little bit is going to be outside of that 99 percentile or something like that. Okay? Is everybody still with me? Okay, so how much is underneath the curve? Underneath the whole curve. 100%. What else do you guys need to know about? Alright, now one thing you do need to keep in mind, even though, yes, 68% of your data lies within one standard deviation, realize that the mean splits this in half. Okay? It splits all of these things in half. So really and truly, between one of these standard deviations and your mean, how much is there? 34%, because you just divide by 2. Okay? Between your mean and 2 standard deviations, what would that be?
That's 47.
What's half of 95?
47.5%.
Okay? So, and this is not just on the one side, it's on both sides, but I'm not trying to make this too cluttered. Okay? What about here? 3 standard deviations.
49.5. Yeah, I was right.
49.5. Okay? So all these are good to know. They're not in your reference booklet. Okay? But they can be applied to your application problems that do deal with your normal distribution curve. Okay? So we're going to take a look at an example, actually a couple of examples, and we'll just do the basic ones today. Okay? Before we look at an example, make sure you get this down. Sometimes you'll be asked to find a certain value using your normal distribution curve, and they're giving you a certain set of data. Okay, and it's called expected value. You can find this expected value by multiplying the number in your sample by the probability. Okay. The easiest example I can give you, if you have a coin, what's the probability that you'll get a head?
50.
Just under 50.
That's
50%.
50%, one half, right? So if you flip a coin
always
50 times, how many times are you expected to get a head? 25 times. So you take the probability, you multiply it by the number in the sample. So in that case, 50.
You flip a coin, you always.
Go. All right, so we're gonna look at this example. All right. Again, make sure you get down the important stuff. Don't get down any of the extra fluff. I just want you to be aware that this is how the questions are going to be presented to you. Okay. The waiting times for an elevator are normally distributed with a mean of 1.5 minutes and a standard deviation of 20 seconds. Okay. That is some information. Now, what do you really need from this?
The waiting time is distributed. Mean of 1.5 minutes and standard deviation.
Thank you, Bradley. Yes. But you also should know what your variable is, what you're actually dealing with here. So waiting times is also important. You know how to shorthand mean and you know how to shorthand standard deviation. Okay? Now A says to sketch a normal distribution curve to illustrate this information, indicating clearly the mean and the times within 1, 2, and 3 standard deviations of the mean. That is the first question. Well, what's it asking you to do? Make the curve. Make a normal distribution curve. If you want to shorthand normal distribution as ND, please do so. Okay? So to sketch this, every bell curve is going to look exactly like what you saw on the previous slide. Okay? It has a horizontal axis, and you do label that horizontal axis. Okay? What's our variable here? What are we talking about? Waiting times. We're talking about waiting times. That's right. So we're going to label this waiting times. Always label it if you ever have to draw it yourself. In your homework, make sure you do it. Okay?
Always.
And then you need to draw your bell curve. Do your best to draw a symmetrical bell curve. Okay? It should be asymptotic to the x-axis. Now, we all know that our mean is straight in the middle, okay? So, you do a dotted line to represent your mean, and you're not going to put the symbol for the mean because you already know what the mean is. It is 1.5.
Or 90 seconds.
Or, you're right, we have 2 different units here, so it probably would be in our best interest to use the same measurement. Good catch. So 1.5 minutes is 90 seconds. So I'm gonna actually put this in seconds too at the bottom. And there's your mean. Now we're gonna fill in our standard deviations because it asks us to clearly indicate the mean at the times within 1, 2, and 3 standard deviations of it. So 1 standard deviation to the left and 1 standard deviation to the right. Now to find those values, all you do is add 1 standard deviation and then subtract 1 standard deviation. That's what was on the bottom, was u minus sigma, u plus sigma. What's 90 plus your standard deviation? 110. You add it to your mean, so that's 110. And this one is gonna be what? Bless you. 70, because you're gonna subtract a standard deviation from your mean. You see how it's coming together? Okay. Now you do your next one. 2 standard deviations. You always subtract when you're on the left side. You always add when you're on the right side. So now I'm going to subtract 2 standard deviations from your mean. Well, 2 times 20 is 40. So it's 90 minus 40. 50. Do the same thing. 90 plus 40. 130. Yes. What you do notice hopefully is that 110 plus another standard deviation will give me that value. So you could do it that way. Just keep adding standard deviations. And the last one, 3 standard deviations, right there on the edge. It's going to be what? 30 and 150. And here is your diagram that represents your normal distribution curve. Yes, ma'am. To get the 30 number, you actually have to subtract 3 standard deviations. Because this is the 3rd standard deviation. Yeah, and it's always from the mean. It's from the mean if you do 2 standard deviations from the mean. Yes. Anyone have a picture? Not too much. Now we're going to answer questions, okay? It says, find the probability that a person waits longer than 2 minutes, 10 seconds for the elevator. So probability, okay? We're looking underneath the curve. We have to figure out exactly what is that probability that a person waits longer than 2 minutes and 10 seconds for the elevator. Well, our curve was based off of seconds, so how do you convert 2 minutes and 10 seconds into seconds? What is that?
Multiply 60 by 2 and add.
60 by 2. Add 10. What is that? 130. So what you do is you go and you look at your, I'm just redrawing out so I have to flip back to the page. You go and look to see, was 130 one of your standard deviations?
Yes.
It was. Was it 1 standard deviation, 2, 3? Which one was it?
3. 2.
Which one was it?
2.
It was 2. So basically, it says you're looking for the probability that it's going to be longer. Longer means greater. So you're basically looking for this probability that is to the right of 130 seconds. Okay? That's when knowing the probabilities really comes in handy. Okay? So 2 standard deviations.
5.
What percentage was that?
95.
Well, it,
47.5 in the middle.
Oh, so it would be 95 plus 2.5. No, it would be plus. Yeah, it would be 2.5, right?
okay, let's see. Let's see this right here. Okay? The mean. What's the probability to the left of the mean right here? This is 50%. Okay? Because always to the left of the mean is 50, to the right of the mean is 50. Now you said that this was 2 standard deviations, correct?
Yes.
What is the percentage between the mean and 2 standard deviations?
47.5.
47.5. So basically, we know what all of this probability is that's to the left of 130. So to find it to the right, we just subtract it from 100.
2.5.
I was thinking that in my head, but I didn't want to.
Exactly. So it's going to be 2.5 2.5%
That was scary. I like it.
of a chance that the person that you pick is actually gonna wait longer than 2 minutes and 10 seconds for the elevator. Do you see how we use the normal distribution curve to get that answer?
Yes.
We can do the same thing for C. It says find the probability that a person waits less than 1 minute and 10 seconds for the elevator. Well, 1 minute and 10 seconds is how many seconds? 70. And we're looking for less than, so we're trying to figure out this probability. Was 70 on our standard deviation? Was it 1, 2, or 3? So if our mean creates 50%, what is that between the mean and one standard deviation? 34. So we can still do it the same way we did before. 34 plus 50, 84. Subtract it from 100, and that's 16%. So if we just happen to get all the people who got on this elevator, and we ask them and say, hey, how long did you wait for the elevator? There's a 16% chance that that person that we asked waited for 1 minute and 10 seconds. Okay? Question? At all. Last one.
They use their field.
200 people are observed, and the length of time they waited for an elevator is noted. So here we go. You got 200 people that got on this elevator, and their length of time was written down, kind of like collecting data. Calculate the number of people expected to wait less than 50 seconds for the elevator. Expected value. You have to take the probability and then multiply it by however many people are in the sample. So you actually have to figure out what was the probability that somebody waited 50 seconds. Less than 50 seconds. Was 50 on your
Yes, it was. The same as 130.
It was 2 standard deviations. Oh, I heard some. What you said?
The same as 130.
It is the same as 130. We figured out that 130 was how much? 2.5%. It is evenly distributed. So if it's 2.5 over here, it's 2.5 over here. So to figure out the number of people, you multiply 200 by the probability. This is a percent. Convert to a decimal. What is that? 0.25 or 0.025?
Hang on that one. Yes, 0.025.
So when you multiply that, how many people
I was correcting you.
should it be? Should we expect it to be how many? 5 people. That's what we should expect it based off of the data that we collected. Okay? And there you go. We draw a normal distribution curve, we analyzed it, we answered questions, we pulled information. You too could do this with the data that you collected. You too.